Hello, everyone. Firstly, I would like to say welcome to our webinar on behalf of myself and my company. And so I would like to introduce myself. And my name is Ahmet. I have been working as mining consultant in Turkey office for 1.5 years. I am providing technical supports, trainings about our mining solutions for both of underground and open pit operations. And so as we determine, we wanted to more near to you during the isolation days of COVID-19 pandemics. And we have planned some webinar series like this. And we hope that the world gets better well in the short time and we may reach out to the old days. So in this webinar, I'm going to show you the Studio OP Autopit design tool. But before to go to the software, I just want a small brief presentation of the Datamine Corporate. So some of you, yes, you know the Datamine software, but some of you not. So I will start with some presentation, and after that I will go through the Studio OP with our today topics. Cool. As with Datamine, is a world-leading provider of mining software and the services to plan and manage mining operations. And our vision to be industry-leading technology provider for the creation, analysis, and distribution of the geological and mine planning information. And you can always reach out to us, always accessible via web, phone, and email, with service location in 18 countries we have now. In that way, you can reach out to us 7/24 whenever you want, and regardless holidays and weekends and etc. Also, our software solutions integrate with our consulting and training services to ensure that we provide our clients with industry-leading support and expertise. So, for example, we are providing some services system such as implementation and training software and some consultancy jobs. For example, for the implementation, we have the ore controller and data blast software, which is the blasting system or the ore controller system. Also, we are providing some services in your sites. Datamine provides solutions ranging from exploration to data management and resource modeling to mine planning and operation to over the 5,000 sites worldwide. As you can see on the product range, we have the softwares from the exploration such as Mapping for Discover and from the resource and reserve model such as Studio RM, Strat3D, Mindscape, or Controller. And also we have some planning and design software such as for OpenPeace, Studio OP, which is I will show you today, and an underground planning solutions, Studio UG and EPS, etc. If you want to take more details, you can see on our website. And today is our topic is Studio OP. Studio OP is one of our flagships for the open pit design and scheduling package. Studio OP is a complete design and scheduling package for the medium-term, short-term planning of the open pit mines, which means the design and visualize piece and pushbacks and bench, dumps, and stockpiles within the Studio OP. Also, you can create the mining units and evaluate against the block models to generate the reserves. And Also, you can schedule them, creating mining units and for the short-term to medium-term mine plan. And today, I will just focus the functionality of the Studio OP. I will just focus the auto design tools of the Studio OP. So the auto pit design tools, the dynamic rules-based approach in which rules are dynamically learned and saved as you interact model the pits. As you can see on the figure now in the presentation, and from the optimized planning model, you can create the pit parameters such as the bench definition and slopes. And after that, you can create pit rims. And after that, you can create contours and you can put the ramps within the pits. And also you can use different slope angles and berm width within the same pit using by the regions and the planning model, lithology, etc. So I will go to do now the software. Some of you you are familiar the interface of the Studio OP, and some guys maybe you are using the Studio RM, also you are or Studio UG also, and they have the same interface like this. If I say explain our main tools, the top of the menu is which is named the ribbons. We say is the ribbons, and under this ribbons we have the 3D screen. The left side, the sheets bar, project bar, which I'm using the files from there. And so today I will just focus on the auto pit design. So I will just be focused just two ribbons, which name is setup and design. So we have a limited time. And let's start with the setup ribbon. In the setup ribbon, Studio OP is using the logical workflow, and the sum icon is now enabled and the sum of R is disabled, and which means it's using now logical workflow. As logical workflow, it means, for example, if you didn't complete the one of the icon, the system will not allow to you to pass the other icons. So if you are, for example, the first user, and if you are, for example, learning the first time Studio OP, it will be very easier to learn to Studio OP. Now, if I select the manage from the pits, now we are in the task window. Task window is a parallel window with 3D, and to ensure you there's a more big working area. And during the auto pit design, generally we are using the task window. In the taskbar, here, obviously we need to define our pit name. So I will write the pit name is webinar. Save. Also, you can create within the same project, you can create multiple pits like this. But in this case, I will just one pit. So I saved. And now I will pass this topography and block model import. In this first step, I will just focus the general things of the auto pit design. And the second example, I will go to the I'm going to use this topography and block model. I came to the define bench. The define bench is very important part of the auto pit design. So in the Studio OP auto pit design, we are creating bench definitions, 3 different methods. Which one is from planning model, and the second one is, for example, if you have a contour strings file, you can import this files for creating the bench definitions. Also, is very traditional method is manual. In this stage, I will use the simple one, manual. I will put to the crest elevation 100. My bench height will be 10 meters. The number of bench is 10. So I click apply. And now as you can see in the table, and my bench definition is automatically calculated, and the level put it from the system. And now in here, if you want, you can change to the bench height using by apply the height to selected bench only, for example. For example, if you want to use my first bench height will be 5 meters, the second 7, and third one is, for example, 15. And as you can see, and when I put to my new bench height, and the other one will be automatically updated from the system. It's very useful. And in this case, I will use same bench height for all benches. I change it again. It's 10 meters. And also you can change the level of the bench ID. And now, as you can see, my crest is the level, but I will change it as top. Now my first bench is 90. So I save it, and I came to the design. When I came to the design, and generally we are defining our slope definitions in these steps. And so in the Studio OP AutoPit design, you can define the bench slopes as 3 different methods like this: manual, planning model, and boundary strings. We will use the 3, no worry. And now I will just use the manual. For example, my face angle will be 60, and my berm width will be 5 meters. And I save it. It's very simple. And so I will go through to the shells and the ramp layout, because I don't have any block model and topography now. So I came to the auto design. As you can see in this case, in this menu, we have the pit names, which is webinar pit, and my phase. Also, I just one phase now, phase 1. And as you know, there is 2 different methods the designing for the pits, and which one is the top down and the other one is the bottom up. In this case, I will use the bottom up. If I came to 3D screen, so I need to select my bottom of the pit. So I will change from the bench toolbar my bottom level. So I will just create a basic string. And I closed. And I would like to more smooth. Now I will use this string as my constraint. So I select my string highlighted and add select string. Add selected string means the system will be use this strings as a constraint of my pits as a bottom. So when I choose the string, and all you need click to recalculate. So now, as you can see, my pit walls has been generated automatically by the system like this, and each walls has 60 degree and 5 meters berm width. If I save it, for example, I will change some rules. I came back to the define slope. For example, I will change my face angle as 40 degree and change the berm width 8. Save it. Again, I came back to auto design. So now all you need to click the recalculate again, and as you can see, my pit walls has been updated according to my new slopes criteria. So, for example, within the pit, I would put the catch berm. So by 20 meter, and I came to the bench constraint. For example, I would like to, from top to down, every 3 benches, 1 set catch berm. So when I click the update, my berm will be updated according to my rules like this, and its system will be put to the new catch berm to my pits. So I save it, and I came back again to auto design and recalculate. So now my 90 RL, 6 RL, and 30 RL will be catched berm. If you click the make design surface, you can create your DTMs. Just one click, you can create all of your DTMs. And so now I will change my slope criteria methods. Delete this one. Can't pick my slopes. I will change my slope again, and I will unload my catch berm. Standard. Okay. So let's use to the region. The region rosette allows to you can define the new slopes criteria according to your azimuth of the pits. For example, in this case, I will use my X and Y 0 and Z minimum and Z maximum from bottom to up, doesn't matter. Minimum 0, maximum like, let's say 100. When I click the plus, my rosette details will open it, and my azimuth 0 will be, I will use the same, my default. When I click the plus, now I see my plan view of the pits. And when I create a new azimuth, for example, for the 90, I would like to use the face angle 70 meter and my berm width, for example, 4. Now, as you can see, my 90-degree azimuth is more perpendicular. Oh, I will change something, and I would like to use 180. Yes, 5. Now, save. Came to auto design again. Hello. I will change my Z transition. Backstring. Calculate. So now, as you can see, the somewhere is deviation there is. So no worry, you can unload this. If you came to the condition, for example, I would like to use the minimum deviation for the some issues where I would like to unload this one. For example, I will use the minimum deviation 1. Maybe we can put some fillet where and again. It's more good. And now, as you can see, the deep pitfalls according to my azimuth settings. If I say yes, for example, I would like to dynamic excavation in the specific bench, and so I would like to use the excavation in the 40 RL this bench. Let's say I will use this mine like this in this bench. I will expand this bench. So it's very important thing is here. For example, if you want to use any constraint, your string must be closed. So I closed this. Once you have created the design strings and add select strings, now you have created strings and just recalculate. And so somewhere again, for example, in this bench, 20, I will create again one, this, and I close the game. Select string and recalculate. Oh, it's very good. And as you can see, our pit walls, top of my new shapes, it will be calculated automatically, and it's very simple and very accurate. So now I will change the slope methodology again. So I will just delete one. Okay. My slope. So I will delete the rosets. So boundary strings. Boundary strings also allows to you your geotechnical strings you can use, and I chose my strings of geotech that I have prepared before. So in the steps, I have 3 different zones for 1, 2, and 3. And each zones I will use different slopes, and let's see how the pit walls will behave. So I will just unload this. So my first will be same. One is more sleep. One is okay. And yes. Open. So I will open my pit data. And as you can see, my geotechnic zone, and each color is shown to us the different geotech zone. So I will create pit constraint within the boundary. So let's say here. So more smooth, and I will copy this. Okay. And as you can see, within the boundary, and I have 3 different pit constraints, and I will choose them and add select strings and recalculate. And as you can see, the red color zone is very perpendicular, like this, 80 degrees. The other one is the more sleep, and the other one is the more sleep. And so if you, for example, if you want to do use the very near together, each together, the strings, let's say them design. Yes, I will more close this. This. Okay, let's calculate. And as you can see, each pit walls show us their geotech zones settings, and my pit zones, this has been created very accurate like this. So for example, I will delete these two strings and let's create a new pit shape like this. And as you can see, each side of the pits has different slope angle and berm width according to my rules. So let's create the ramp of the pits and have a look what is the behavior according to my geotechnical zone. So I will create a new road and its name will be road 1 and gradient will be 10. I will use the percentage. Also, you can use the different gradient methodologies. I will use the percent. So my width will be 50. And also you can change the direction clockwise and counterclockwise. And also you can change the entry distance of the roads. If I say to choose start points of the roads, let's say from here. Now my roads has been created automatically by the software. From bottom to up, my road segments will be created, and also you can change to the roads, and also you can edit the roads settings from the edit roads menu. For example, I would like to change to my start points, my ramp, like this. Also, you can choose the different level. You can start any roads, and also you can end the road segments. For example, just I would like to use the one segment of roads, and or you can continue to roads using the upper. These. Good. And you can add a switchback for turning off the roads. I click anywhere, I change to my roadway. And for example, you can extend the turning diameter, right? So the radius. So for example, switchback, I will use the 7 meter at switchback, more width for the turning. Good. And also you can change again the roads, and it remains of the turning switchback. It remains still within the pit like this. So, for example, if you would like to changing of the gradient of roads, you can put the new gradient, for example, 15%, and select edit. For example, from start to end, and my rows now have 15% degree, 15%, sorry. And also same method, you can change the width, my road, sorry. Let's say 20, And now, for example, I would like to use specific segments. These you can create different widths within the same. So I will change again. Sorry. Okay. In entry distance, which means, for example, in the start of the road is very narrow. So if you would like to extend this way, you can create a new entry distance. This 70 meter, apply, and now your start of the roads is more good. And from the from the berm tapering menu, we have the some rules in here. And so, for example, in this stage, I would like to focus the flat road distance, which was commonly used by the users. And the flat road distance is ensured to you the each of the segments. If you would like to, for example, the flat roads, the between of the segments, you can create a flat distance. For example, in this case, I will use 20 meter distance each of the between each segments. I will create, and now, as you can see, my each road segment has 20 meter flat road distance, like this. So now I will go through with the surface topography and block model now. So I will create a new feed, webinar _2, save it. And if I come to the surface topography in this stage, and we are selecting topography in the wireframe or triangle file, and you wish to associate with each bit, so you just need import to your topography. My topography is here. If you click the checkbox, now you see our topography. So I am linking to my piece to this topography, and I save it. And if you are interested, I am just following the logical workflow like this, from left to right. So I came to define model. In this stage, I will import my block model, which is I exported to from the MPV scheduler optimization software. So, or you can use a different optimization software, or you can use the geological block model, doesn't matter. So within the block model file, we have the some fields, and the assignment is, which means we are assigning the auto-bit design methodology. In the density, it will be density. The system will be automatically recognize your, for example, grades and density if you wrote and the capital of the all capital of the words. So density will be default 2.75, and my grade will be default 0, 0, and I will change the level for AU, gram per ton. And my MPV destination will be category, because I would like to take the report as the tonnage and the volume. According to my each material will be go to the where. So In this step, very important thing is here, the pushback bits, I assigned the optimized phase. The optimized phase, which means this automatic pit design will be calculate your pit shells according to your block model fields. So I chose the pushback bits will be my optimized phase, and so I have 3 different pushback in this block model, and let's see what will we get. Save it. And so we will use now the define phase. And I will change to my pips webinar 2. And now the use model is enable. Change the enable and initialize. So now, as I said, and we have now three different pushback within the block model, and the system show us automatically the pushbacks. Okay, and I came to define banks. As I said again before, you can use 3 different methodology for the bench definition, and we have used the previous steps manual. Now we are changing the methodology from planning model that I will use. So I click the planning model and apply, and as we can see, my table will calculate automatically from my block model. So my bench height will be calculated according to each block of the Z INC. So I click save, and I came to the design. So now I am changing again my slope methodology, and so in previous steps we used the manual and boundary strings and rosettes. Now we have different methods for the slopes from planning model and lit. Within the block model, we have the numeric lithological fields, and so I will use this field as a slope region criteria. So as you can see, we have 4 different regions, and so I will wrote a new berm and face angle according to my lithology. First lithology will be 38 degree, berm 7, and 51 degree, 6, 6 degree, 5, 7 degree for 4. And you must enter the default region, face angle and berm width. So I will use the 4th region, same width, same angle. So I click save. So now we will use the shell contours. As you remember, we have imported the optimized block model, and now in these steps I will create the shells according to my block. So I am changing to my last pushback. So I would like to use the more smooth to my wireframes. And if I say generate from model, the system will be create for me my picture for pushback 3. So if I put to my block model, as you can see, my 3rd pushback include my all blocks. So for example, to my pushback shell, I would like to create the bench contours. So according to my bench definition, so when I select the bench, all I need click to generate. So there may be some smooth for my contours. Use splines. Like to interpolate easier. Yes, more good. So I save it and come to the auto design again. So in this step, the previous steps, for example, we have created our new constraints from the new constraints from my hands. So, but in these steps we are using the block model and the pit shelf. So we don't need to create any constraints. So I will choose the whole strings for the design. And as I said before, for example, you would like to use as a constraint the strings, you have to close this strings. So I will close this strings and I will select the whole strings as constraint. And now, as you can see, my constraint is here. And all you need, click the recalculate. Now my pit walls has been created automatically according to my pit constraints and contours. So in the steps, for example, I will show you some settings about the pit design. And so, for example, the bottom of the pit is very narrow. For example, let's measure 1,500 square meter. For example, it's very narrow for you, and you would like to unload this. And if you come to the conditioning menu, and you will see the minimum area. So, for example, I don't want to create any design the less than 2,000 square meter, and I put the 2,000 minimum area, the less 3,000, and you will see my bottom of the base has been unloaded. So, if you show to topography, and now you see the over of topography my pit strings, and so you don't need to mind here, you cannot mind here. So the system has a strong functionality of this. For example, if you select the mark design strings above topo and click recalculate, and now you see my above of the topo has been marked as dash. So it will be very easy to creating the roads because where I need to finish the rows, it is very valuable for us. So now let's create a new roads width. New adaptive roads will be, for example, 1 twice. Okay. So in this here, I will finish this rows. Here, I will just one segment for bits. Enough. So maybe here. Okay. So and enter distance B. Good. And the other toe is I will create new roads in here in clockwise. Okay. Again, I will end this road here. And enter distance again. So I'll create my last road segments 3. Yeah, very good. And I will finish the above of the topo. I will finish the roads, for example, in here. No. So if you click to make design surface and your DTM has been created, this, and for example, if you select the combine design surface with topo, if you check it this, make design surface again, and your design has been linked with your topography. And so, for example, if you would like to intersection strings with topography and PIDs, and let's add trim to design strings when making design surface tool, and recalculate again, and make design, and now you can see my string, my PID trim. So when you come to the evaluate is ensure to you evaluation of the against the block model, your PID volumes, and let's say evaluate, and now you see my according to my MPV destination, I see my tonnage, total tonnage, each material will be sent. Plant oxide, sulfide, and dump. It is dynamic calculation. For example, if you would like to excavation in here, and auto evaluation also I will use. Here, for example, I will create this one. Like this, and let's select string, calculate, and make design surface, and my total tonnage will change. It has been changed according to my new excavation. So also you can change to the evaluation legend from the advanced tab. If I select the override default legend, let's say AU training, and or I would like to create legend AU, and let's create design surface, and as you can see, my total tonnage according to my grades: low grade, medium grades, high grade, and very high grades. So let's put 2 strings and block model time period. It's very good. So during this webinar, we have completed the general things about of the AutoPID design. I hope that it was valuable for you and you enjoyed. And if you have any question or comments, do not hesitate, contact with us. And I hope to see you next webinars. I wish all of you have good and healthy days. Thank you so much for your time.